Okay, thank you very much. My name is Javier Bustamante. I'm coming from Doñana Biological Station in Spain. And my talk is about the system of vernal pools in Doñana National Park. It's one of the largest and most extensive systems of vernal pools in Europe. The system consists on a deposit, aeolian sand deposits that were formed during the Quaternary enclosing the mouth of the Guadalquivir River. These sands act as a large sponge and are staying on top of a large partially confined aquifer. On these sands we can find over 3,000 water bodies that range from large permanent ponds, a few large permanent ponds, and other more ephemeral ponds that can have hydroperiods ranging from several months to just a few weeks in very rainy years. The area has been receiving different levels of environmental protection. There was a national park that was created in 1969 and is represented here in red. The area was expanded, the protection was expanded in 1988 with the creation of the natural park. Later in 2012, the Doñana Biosphere Reserve was expanded and enclosed to another part of the Aeolian Sands. And there is a fourth part which is not receiving any legal protection and it's shown there in gray. The system has got different pressures, environmental pressures in relation to water. There is irrigation agriculture on top of the aquifer that is using surface water but also groundwater. We also have residential areas that are taking water for human consumption but also for recreational purposes. So our main interest was to find out which were the effects of this water abstraction pressure on the system and also whether the different levels of environmental protection had an effect on the hydrodynamics. We used remote sensing data. We were interested in seeing whether remote sensing data with relatively medium resolution sensors like Landsat was able to pick up the trends in the system. We used the Landsat series from 1985 to 2014, 30 years of data, over 300 satellite images, from which we constructed flood masks, and from this we were able to estimate annual hydroperiods using around 11 images per year. What we get actually is how long each pixel remains flooded in a year. Just show very few results, but what we get is that we can see these are the average hydroperiod duration in relation to the level of protection. We can see that the national and the natural park have a very similar dynamics. They fluctuate quite widely, differences between the years, and they tend to be very much correlated. Biosphere Reserve and the unprotected areas show much smaller fluctuations if you just check the range of the y-axis. The main thing that you see is that there is a trend in increasing hydroperiod both in the Biosphere Reserve and the unprotected area, while rainfall has not changed very much. There is a correlation between rainfall rainfall and hydroperiod duration, especially in the protected area. And once we correct hydroperiod for rainfall, we analyze the trends in hydroperiod duration, and we see unexpectedly that close to irrigated areas, hydroperiod tend to increase. Also, another important factor is that hydroperiod length is not very much, well, has not had a trend in the protected area. The high protected area is the national park, the medium is the natural park. But there has been a decline in the areas of the Biosphere Reserve, and unexpectedly the unprotected area has got an increasing trend in hydroperiod duration. So to conclude, we have seen that the protected areas in the Aeolian Sands hold a much better preserved system of temporary ponds with a flooding dynamics that fluctuates with rainfall. And contrary to our expectations, the unprotected area shows an increase in mean hydroperiod duration, also an increase in surface flooded, and a decline in hydroperiod variability. This is just a very short summary of our results that you can just check in a paper that we published last year in Remote Sensing. Thank you very much.
Thanks. Thank you, Javier. I would like to invite Priscilla.
Hi, good morning. I'm Priscilla Molina Perez, and I work with Mary Grace Balinos and Irina Montenegro, and we are the planning and monitoring program of WWF Chile. And on behalf of my team, I'm going to share with you the advances of monitoring and impact evaluation in southern Chile. So WWF Chile has been working in the southern Chile for 15 years, and 2 years ago, we launched our strategic plan. So along with this, we've been developing and implementing a monitoring system in order to know if we are accomplishing the outcomes of the strategic plan. So monitoring also is part of the project cycle that we've used in our conservation work. And also it has the advantage of improve the accountability and transparency, improve the communication with better data, and also the decision-making process, adapt the conservation strategies, and make better advocacy. The general structure is that we have two main work streams. One is for monitoring the conservation strategies, and that is based on the goals and objectives. So we have then the monitoring plan. And the other one is very specific for the impact evaluation of sustainable certification scheme. One is for the salmon farms, which is the ASC certification, and the other one is for forest plantations in southern Chile, which is the FSC certification. So then we have the impact evaluation protocol. For the case of impact conservation strategies, we start with our strategic plan, and then we have our outcomes and strategies, and then we work towards the development of theory of change, where we have goals and objectives, and then we develop the indicators. So we have the monitoring plan. Also, we use GIS, Geographic Information System, with primary and secondary data. We have the spatial data infrastructure that help us to improve the use of this tool. And then, so we have like information from the government. In this case, we use the land use information that help us to build attribute table with quantitative data, and that so we can see the threats for our conservation targets, and in this case, the native forest, like agriculture, the forest plantations. There we have our conservation targets that in this case were showing the native forests of the Valdivian ecoregion, and also the protected areas. And we share this information with a global platform from WWF, which is Global. The other one is that in the case for FSC certification, we develop indicators and a methodology in order to assess and monitor the impact of this kind of certification using GIS and satellite image, and there is the relation with remote sensing. So we have the impact an impact evaluation report. The key message is that we do monitoring and impact evaluation, and it will depend on the objectives and the scale, because it is different to monitor a species, a project, or a program. Also, GIS and remote sensing becomes critical inputs for monitoring and impact evaluation. And the other one is that to overcome the restrictions on data access and information gaps, it is important and crucial the alliances with other organizations, the government, and the academy. Also that the last but not least, monitoring indicators must be simple, feasible, and easy to analyze. I know that it is hard to do, but you should try. And well, we invite you to join us at the workshop at 1:30, where we will be sharing the lessons from the impact evaluations from these certification schemes. And thank you.
Thank you. Very interesting. I would like to invite Ned.
Oh, sorry. Good morning. While we get this going. All right, thanks. Okay, so the goal of the initiative that I'll be talking about today is to improve the efficiency and accuracy over traditional and often manual methods for identifying and classifying images or features in an image. And humans are still better than computers at identifying and labeling objects, but computers are getting much better. And that's evidenced just by the fact that driverless cars are becoming a reality. And I'm doing this presentation to present some of our research ideas and hopefully foster some collaborations as we progress in this research. Oops. The foundation of our work is deep learning neural networks. The early stages of a deep neural network is to try to mimic the visual cortex as it finds patterns and learns to identify objects. More complex features are found in deeper layers of the network. This approach can be contrasted with the traditional remote sensing methods where we create algorithms and instruct the computer how to define and locate spectral and spatial patterns. Using deep learning methods, we're letting the neural networks figure all that out for us. When we work with images, we use a special type of deep learning neural network called a convolutional neural network. These algorithms take rectangular sections from an image and label that image section as an object, such as a deer or a forest. In other words, it answers the question, what is this an image of? The convergence of a few factors are influencing the rapid increase in the use of convolutional neural networks. One factor is improved algorithms, and that's enhanced with ever-increasing improvements in computing power, such as improved high-throughput graphics processing units, or GPUs, and cloud processing that can distribute processing tasks over hundreds or even tens of thousands of images. Oops. Improved computing efficiency is paired with an increase in image acquisitions. For many users, new imaging hardware and camera platforms are the most noticeable advancement in the field. The recent surge of consumer drones has piqued the interest of a lot of conservation researchers and practitioners who are going out and acquiring digital photos and video, but many users are not sure how to process and use these data to extract useful information. Also of interest are micro and nano satellites that fly in constellations of dozens or hundreds of satellites. Innovation of new camera and mounting devices is allowing cameras to be mounted on animals and in remote locations in ways that was not practical in the past. These innovations in turn lead to an enormous backlog of images that need to be processed. This new image processing workflow that we're working on will greatly improve our ability to process these images at a faster rate. So the work that we're doing is focused on three areas. The first is image classification. And we're working on an alternative approach to traditional pixel by pixel and image segmentation classification that would typically be used to map different land cover types. Our approach is to use a convolutional neural network scanning system to incrementally refine the classification from a very blocky, low-resolution interpretation to a finer resolution that's suitable for the intended use. Another focus is on identifying and labeling specific objects in an image. This slide shows an example of a camera trap image, and it has identified 3 deer. The goal is to reduce the human effort required to identify camera trap photos of interest, which are usually only a small percentage of the images that are acquired. The third focus area is on object counting. The first step of counting is locating the objects to be counted, and the next step is to apply an algorithm to count isolated individuals and also clusters of individuals. This is an image of flamingos that has been this is an image where flamingos have been separated from other features, including other birds, and the next step is to count the flamingos that are in the image. Looking into the future, we have a few tasks ahead of us. One is to get some funding to continue our work, and funding tool development is historically difficult to find. To help improve our chances of getting funding, we're interested in forging new collaborations with folks who are doing similar work or people that have problems that we might be able to solve with this technology. We also want to develop some performance metrics so we can compare our algorithms along with other algorithms to better understand where they perform well and where they don't perform so well. And in summary, we're trying to push or find and push the limits of image science applications in conservation. I hope to continue to share ideas either in the discussion session or just throughout the conference or by email because we really want to make this happen and we think it can be very useful for other folks. So we look forward to further collaborations. Thank you.
Thank you. So, Leonor.
Buenos días. Yo les voy a presentar una nueva herramienta que hemos venido desarrollando dentro de WCS para la Corporación Autónoma del Amazonas en Colombia. El objetivo de este proyecto fue desarrollar un programa de monitoreo que ayudara a la toma de decisiones y fuera inmediato. O sea, gran parte del problema que tenemos es que los tomadores de decisiones no tienen acceso a la información y ese acceso puede ser demorado. En ese sentido, nosotros generamos un esquema de trabajo en el cual generamos protocolos, parametrizamos las obligaciones que tienen que ver con el monitoreo de las actividades planificadas que están asociadas a todo el aprovechamiento forestal, identificamos un área piloto, revisamos las variables asociadas a esa área, estandarizamos los datos, entramos los datos y por otra parte empezamos a generar búsquedas automatizadas utilizando programas libres como MySQL, que es una base de datos que está asociada a todas las actividades planificadas, y en PostGIS, de tal manera que la información de MODIS generada por TRI pudiera ser automatizada y utilizada dentro de la herramienta. Construimos la herramienta utilizando también servidores de libre acceso y en este momento ya tenemos una herramienta de monitoreo que funciona y está siendo adoptada por la corporación. La corporación, o sea, para mantener una no pérdida neta de biodiversidad, es necesario generar una planeación, una evaluación y un qué hacer. En ese sentido, nosotros identificamos como objetos de conservación los bosques, la distribución de algunas especies focales y de especies maderables. La herramienta, por lo tanto, permite evaluar 2 tipos de indicadores. Indicadores espaciales que permiten determinar el estado y balance de esos objetos de conservación y indicadores alfanuméricos que están asociados a la información que colecta directamente la corporación en terreno. De esa manera, la herramienta permitirá tomar decisiones en cuanto a la priorización de áreas para aumentar la efectividad de los programas de control y vigilancia, identificar zonas para la restauración y conservación, definir cómo deberían ser los sancionatorios y los procedimientos ajustados a esas actividades planificadas, definir las obligaciones en términos de compensación y planes de manejo y, por último, identificar la efectividad de la planeación que se está realizando. Este es un esquema de cómo está la herramienta en Internet y algunos resultados que hemos encontrado para este último trimestre del año. Con respecto al control y vigilancia, vemos aquí un resultado para Caquetá, uno de los departamentos con mayor tasa de deforestación en Colombia, y vemos que muchos de sus municipios que se encuentran en rojo presentan tasas de deforestación neta superiores a cero. Y algunos municipios que están en verde presentan tasas de deforestación positiva. La herramienta también permite identificar cuáles son las zonas donde ha ocurrido deforestación y identificar cuál es el papel de las áreas protegidas dentro de esas zonas. Por ejemplo, en este caso, en el área protegida solamente se ha perdido menos del 1% del bosque durante este primer trimestre del año. También permite identificar cuál es el efecto de las actividades planificadas y el estado de las especies maderables. En este sentido, permite identificar cuál es el número de individuos por especie que se encuentra presente en la zona, teniendo en cuenta las pérdidas y ganancias por aprovechamientos forestales. Para las especies también permite obtener gráficas en las cuales se ve cuál es el estado por especie que se ha encontrado en la región, en el municipio, o teniendo en cuenta el sector productivo que lo está utilizando, ya sea minería, hidrocarburos, etc. La herramienta también permite incorporar nueva información. Con respecto a la imagen de satélite que se está utilizando, la información de Terraí permite actualizar automáticamente todos los datos nuevos que se generan a partir de MODIS y que Terraí procesa para que puedan ser utilizados. De igual manera, permite actualizar la capa de bosque para Colombia generada por el IDEAM. También permite incorporar información nueva con respecto a la planeación del uso de la tierra para determinar cómo está funcionando esas nuevas áreas y para incorporar también distribuciones de especies focales que sean de interés, que no estén en este momento incorporadas en la herramienta. Lo que esperamos entonces es que la herramienta de monitoreo permita tomar decisiones a tiempo y conlleve a una no pérdida neta de biodiversidad y un uso sostenible de los recursos. Muchas gracias.
Thank you. Viviana, here.
Good morning. Thank you for coming. My name is Viviana Gomez. I will present our work in relating to mammal occurrence to remotely sensitive ecosystem functioning in fragmented landscape. Understand the consequences of habitat fragmentation is critical to preserving biodiversity and its role in maintaining ecosystem functioning. The functional heterogeneity of an ecosystem should be represented by the carbon capture and its temporal dynamics. Forest loss and fragmentation affects the ecosystem function, altering patterns in primary carbon capture, and land cover change into agricultural lands increases the intra- and interannual variability. One index, an ecosystem serving provision index derived from satellite data, was developed as aggregated indicator of the status and trends of ecosystem supply. This index SP is based in two attributes of the seasonal dynamics of the NDVI, the mean NDVI and the coefficient of variation. The mean is a proxy of productivity and the coefficient of variation as a proxy of seasonality. SP was related with carbon and water dynamics and biodiversity, and correlation was high. And in our work, we used SP as a proxy of habitat heterogeneity and availability. For example, double crops, single crops, or natural covers. We hypothesized a positive relationship between SP and mammal richness and occurrence. We estimated the SP value at landscape level during the one hydrological year in the southern Chaco, in where agricultural expansion was high. We detect mammals with camera trapping in 17 landscapes with similar sampling effort per landscapes, and we found 44 percent of correlation between SP and forest area at landscape level, but no significant effect on estimated richness at landscape level. However, we found some effect at species level, and we think that species conservation concerns with benefit from the ability to monitor change in habitat heterogeneity and habitat availability from functional attributes derived from remote sensing data because they respond faster to environmental changes than structural attributes. Thank you.
Okay, good timing. Joelisoa, next speaker. Thank you.